Hi, thanks for joining me. In this video segment, I'm going to be looking at decomposition and synthesis. I like to do them together because they are often just the opposite of one another, especially when it comes to the rules that have to be memorized for these. Sometimes synthesis is called a combination, so you might see other types of names for these depending on the textbooks. So if you have an element plus an element, you're going to make a binary compound and you simply use your formula writing rules. If you have a binary compound, the only thing it can be decomposed to form is its elements. So that's what I mean, they tend to be opposite of one another. Metal oxides plus water form bases or hydroxides. Metal oxides are often called basic anhydrides. Something that is covered in IB, for example. Okay, non-metal oxides plus water form acids. Non-metal oxides are called acidic anhydrides. Okay. Metal chlorides plus oxygen make the metal chlorate. Just like that. So if you look at that rule, bring it right down here. Metal chlorates make metal chlorides and oxygen. Okay, metal oxides plus CO2 make metal carbonates. Metal carbonates decompose to make metal oxides and CO2. So for many of these, if you've learned one rule, you've memorized the other. Decomposition is typically primarily about breaking bonds, which requires energy. So you're going to be looking for words like heated, electrolyzed, or flat out said decomposed. They'll use a catalyst. Manganese for oxides, a popular catalyst, especially for hydrogen peroxide. Heat, electricity, and catalyst, those are all shown above the arrow. So you'd put the arrow from your reactant to your product, and you'd put a triangle, for example, for heat being applied. Okay? So let's take a look at a handful of these and then evaluate to see if it might be a redox. So in this case, I have potassium reacting with chlorine gas. All right, I've got two elements. The only thing they can do is make a binary compound. Potassium becomes +1, so I'd have K+, and chloride becomes -1 ion. It might help you to write those ions separately, and then we would need to balance it. So is this a redox? Well, whenever you have elements going into a compound, you know it's a redox. In this case, potassium 0 went to potassium +1. Chlorine 0 went to chloride -1. Okay? Carbonic acid, H2CO3, is heated. And carbonates go to H2O and CO2. That's what happens with soda pop. And that would be a gas. This would be a liquid. That's aqueous. That's what happens when soda pop is opened up. So that tends to be an equilibrium depending on the pressure, which way it goes. This one is actually not a redox. And I don't think you would have to identify that if you were in 10th grade unless your teacher covers oxidation numbers. If you assign oxidation numbers to these, you would see that none of them change. But for sure, you can tell by the element going in and out. Chunks of calcium oxide are tossed into water. Okay, metal oxides are basic anhydrides. So I'm going to make calcium hydroxide, in this case aqueous. Chunks would imply solid, that would be a liquid. Okay, this again is a no, and if you're not required to assign oxidation numbers, I doubt you would have to identify this one, right? And everything is balanced there. Oxygen. A stream of hot oxygen is blown over strontium chloride. Okay, and this is an ionic compound, so it's a solid. And if you look at your rule, oxygen plus chlorides, so metal chlorides plus oxygen makes the metal chlorate. So we're going to make strontium chlorate. So I need to put a 3 here to get my oxygens to balance there. Is this a redox? Well, oxygen is 0 here, and oxygen is not 0 in a compound. So for sure you can get that much down if you are not taught how to do specific oxidation numbers. Calcium carbonate is decomposed. If you look at your rules, carbonates are decomposed to form the oxide, calcium oxide, plus CO2. And this happens to be a no for the redox. Okay, so hopefully that gives you a general idea. These are in some ways the easiest to predict because it's rules to memorize. You don't have to figure out what the products are per se. You memorize a rule. So some people find that a little bit easier. I hope some of the insights I have given you some guidance. Thanks for joining me.